Okay, let's say that I'm drawing two lines here, and these two lines represent the walls of a capillary. And inside the two lines is the inside of the capillary. Outside the two lines is the interstitial fluid. And we have forces that control movement of fluid into or out of the capillary. So, for example, we have hydrostatic pressure, which is basically the pressure created by the blood pressure in the capillary, and hydrostatic pressure normally pushes fluid away from it. We also have oncotic pressure, which is pressure created by proteins in the fluid, and oncotic pressure generally pulls fluid to it. And so inside the capillary we have hydrostatic pressure. Inside the capillary we have oncotic pressure. We have a little bit of oncotic pressure outside the capillary, and we have hydrostatic pressure outside the capillary. But this hydrostatic pressure outside the capillary is a little bit strange because fluid in the interstitial is constantly drained away by the lymph system. And so the value on this hydrostatic pressure is going to be negative. Which means that instead of pushing fluid as it normally should, this negative hydrostatic pressure pulls fluid to it. So that one's a little bit strange. The hydrostatic pressure in the capillary pushes fluid out. The oncotic pressure in the interstitial pulls fluid to it. This oncotic pressure within the capillary pulls fluid to it. So if we look at these pressures, we have 1, 2, 3 pressures that are forcing fluid out, 3 outs, and we have 1, this oncotic pressure in the capillary pulling water in, that's 1 in. And if we know all the values of these pressures, we can actually calculate the net force and whether fluid is moving into or out of the capillaries.